Hello and welcome to the Advent of Code 2021, day 9. The problem today for the part 1 gives us a matrix of integers, and what we have to do is to simply find all the values in this matrix that are surrounded only in the vertical and horizontal axis, so ignoring diagonals, by values that are higher than the value in the center. We ignore, as say, diagonal values, and also we ignore values on the border. So essentially, for example, here this 0 value will be considered local minimum only because the numbers that are immediately below and immediately on the left are greater than that. Seems a very simple problem, so let's immediately do it. First of all, we have our input, which is a huge list of numbers which describe a sort of grid, and we parse it. So we define an empty grid like this, and for every line in our file we add to the grid with append. We add what? That specific line in terms of integers. So we say int of a value for v in line, and maybe we also split the line, strip the line, because it will have the new line character or other stuff like that that we do not want. And this grid that we created is simply the input for our problem. Let's print the grid to be sure that it contains what we need, and we can also run the code. Okay, so it seems good. Let's see, for example, that the last line matches what we have here, and we do not have lines that are ignored. It ends with 879, this ends with 879. Seems correct. Let's see how to implement the part 1. First of all, we have for every value in the grid to find the neighbors, so the 4 values that are immediately above, on the right, left, or down. So first let's iterate over all the possible values in the grid. I say that for, let's call it x in range that goes from 0 to the length of the grid, so the amount of rows that are there. I put another for cycle, this time iterating over y. What is the range is essentially the length of a single row, so not the length of grid, but the length of grid, for example, at position 0, because it's not necessarily a square. Now what do I want for every x and y? I want the values that are around this specific coordinate, this specific x and y. To do that, I will define a function. So I say that neighbors, this is the American spelling, I'm fine with that. I call it get neighbors. What will this function receive? We will receive the grid itself, then x and y. Once we get the neighbors, which will be a list of the values that are around this specific x and y, we want to check whether the value that is at position xy, so let's call it current, which is the element that is at position x, y. We want to say that if current is lower than the minimum of neighbors, we have the result, which is a sum of the value that we have in current plus 1. So the problem is saying that the risk level, they call it like that, is 1 plus its zeta, so plan plus the value of the local minima. Once we do it, we return the total. So we find all the local minima, so all the values that are surrounded only by values that are strictly greater, and for each one we return that value plus 1. Now all we have to do is to define this function getNeighbors. So we create this getNeighbors, which is a function. What will it do? We'll have a list of values, initially empty, and one by one we will check the 4 possible cells that we can have and add their value to the result. So return ret. So let's check first of all that we are not on the edge. So we say that if x is greater than 0, then ret will have the value that is at position grid x minus 1. We check that x is strictly greater than 0, which means we are not on the left edge, so we can just go 1 below, so we will not have the risk of reading something that is outside the matrix. And the epsilon coordinate is the same. Every time we shift of 1, adding or removing 1, either x or y. So we find the coordinates of the 4 cells that are immediately above or on the side of the current one. Exactly the same goes for y. So we said if y is greater than 0, we can easily get the coordinate x and y minus 1. Because we check that it's greater than 0, so we can remove 1 and get a valid coordinate. Those are the 2 conditions for adding the cells that are not at the edges. And then we have the same thing for the other edge. So we have to check that the x is lower than length of the grid. So it's not on the extreme right of the grid. Minus 1. Minus 1 because the length is shifted by 1. So if we have, for example, 5 values in the list, x will go between 0 and 4. So we have to remove 1. And here, instead of minus 1, we have plus 1. So we say, if we are not on the edge, we can go 1. We can increase of 1 the value and still have a decent possibility. Same thing goes with y, with the difference that, of course, this time we do not use the length of the grid, but the length of the row 0 of the grid. And of course, now we increase y by 1, not x. And that's it. So we return the 4 values. This will be a list of integers. And this seems to be already a solution. So it's a very simple problem today, at least for part 1. Maybe part 2 will be super awful, we don't know. Okay, I get 456. Of course, the value changes every time. And that's right. So see you for the part